We're going to continue with section 2. Today is, the notes are 2B. And today we're going to solve rational equations, in other words, fractions. So what we're going to be doing is we're going to eliminate the fraction by multiplying all the terms in our equation, or every single thing, by the LCD. Now, what's different with this is we must check our answers for extraneous roots. And what I mean by that is if there is a variable in the denominator, we need to make sure that the answer we get doesn't make that denominator equal 0. Because if you have a 0 in the bottom of your fraction or in the denominator, it's undefined. You can't divide by 0. So we're going to only check when there's a variable in the denominator. So let's go ahead and we're just going to do a bunch of examples. So the first one, notice on this one, there isn't a variable in my denominator. So this one I'm not going to have to check. Now remember, just like before in the 1.2a, you can always, once you get what x equals, you can plug it back in. Now, I'm going to go ahead and find my common denominator, or my LCD, between 3 and 4, and that's going to be 12. Now, we can do this two ways. You can either just surround the original problem and put a 12 up here, and you're going to distribute the 12 to each thing. Now, what I like to do is take each term and then put the 12 in front of it, so I can see for myself what's simplifying here. So what I'm going to do is I'm going to show that I'm going to multiply 12 times the x over 3, and then I solve the plus sign. Then I'm going to multiply the 12 to the 3x over 4, and you also have to do it to what the equation equals. And again, I'll multiply 12 to the 2. Now, what I'm going to do here is simplify diagonally. So I'm going to simplify, and I can divide 12 by 3, and the 12 now, this becomes a 1, this becomes a 4, and now I'm only left with multiplying 4 times x. Then I'm going to do the same thing here, simplify diagonally, the 4 becomes a 1, the 12 becomes a 3, and then I multiply 3 times 3x, and I get 9x. Then I'm going to do the same thing over here to the 2. Nothing to cancel on this one. If you wanted to see like an over 1, this just becomes a 24. And now I don't have any fractions to deal with. So now I'm going to go ahead and combine my like terms. I get 4x plus 9x gives me 13x equals 24. I need to divide now by 13. And x equals 24 over 13. I'm okay with you leaving it improper. You don't need to make it a mixed number or a decimal. Now on WebAssign, just read. If they say, you know, write your answer as a decimal, then you'd have to divide it. But I'm okay on the quiz on Thursday for you to leave it as an improper fraction. Now remember, if there were a variable in this denominator, both the 3 or the 4, then it would be mandatory that I check this to make sure that it doesn't make any of the denominators a 0. If you want to plug it back in and check your answer, you can, but you don't have to. Let's try number 2. Same thing on this one. Notice there is no variable in the bottom, so my check for extraneous solutions isn't happening yet. So now I'm going to look for my common denominator between 5 and 3, and that's going to be 15. Now again, you can either show it like I just did, or you can just put the 15 once and then just remember to distribute to everything. Again, I'm going to put it next to each term. It just makes it easier for me to see what I'm canceling. And then here, put it next to the 5x. And then the last one, the 15 times the 4 over 3. So now for the red one, the 5 and the 15 becomes a 3, and the 5 becomes a 1. And now I'm left with 6x, Then for the blue, nothing to cancel here, so I have to multiply 15 times 5, and I get 75x. And then for the purple, the 3 and the 15 will simplify, and the 15 becomes a 5, and the 3 becomes a 1. So 5 times 4, and I get 20. Now I'm going to combine my like terms. 6 plus 75, they're on the same side of the equal sign, so I'm just combining like terms, and I get 81x equals 20. I'm going to divide both sides by 81. And my final answer is 20 over 81. Nothing to simplify here, so that's your final answer. Now, we're not going to have to check for extraneous till we get to number 4. Number 3 is the same scenario. No variables in the denominator yet. So I need to find my common denominator between 5, 2, and 10, and that's going to be 10. So again, I'm going to multiply my first term by a 10, the second term by 10, and then I have the equal sign, and then I have 10 times 3, and then the last one, 10 times 3x over 10. Again, I like to do this so I can see what simplifies, but again, if you would have rather just surround this and then distribute a 10 to each thing, you can. Either way. But I'm going to simplify here. The 5 and the 10, this will become a 2 and a 1. So then I'm left with a 2x. And then over here, what will simplify is the 10 and the 2. So then the 10 becomes a 5, the 2 becomes a 1. So now I have 5x. And now nothing to simplify, so it's just 10 times 3. And then the 10s will cancel on the pink, and they both become 1s. So then I'm just left with 3x over there. So now I need to combine my like terms on the left. So 2x minus 5x is going to give me negative 3x. Drop down the right side. I now need to move the x's together. So I'm going to subtract 3x. And I get negative 6x equals 30. I now need to divide both sides by negative 6. And 30 divided by negative 6 is negative 5. Again, if you want to plug that back in to check to see if the two sides equal, you can. But we don't have to check for extraneous yet. Now on number 4, this is where we're going to have to check after we get our answer. So for number 4, notice this time my common denominator is going to be x. So I'm going to go ahead and multiply each term by the x. So x and then 15 over x. Then the next term, x times the 4. And the next one, x times the 6 over x. And then the last one, x times the 3. So again, on the first one, the x's are going to cancel. And I'm left with just 1s. So the first term is just 15. The next term is going to be 4x. Then the equal sign. The purple, the x's cancel. So I'm just left with the 6. Then the pink, just multiply, nothing to cancel. Now I need to get my like terms together. Now, it doesn't matter which way you move your variables. I know a lot of people like to move them left all the time. There is no rule that says you always have to move your variable to the left. It's whatever you're more comfortable doing. Just get your letters on one side and the numbers on the other. So I could move the 4x to the other side or the 3, it doesn't matter. But that's gone. And then I get 7x. Then I need to move the 6. 15 minus 6 is 9. Divide by 7, and x equals 9 over 7. It won't simplify, but now remember, we need to see if it's going to make any of the denominators a 0. Now, when I do this check, I do not have to plug it in and simplify everything down. I can, and that'll give me to make sure that my x is correct, but all I'm doing is looking at what's in the denominator, and only thing that's there is an x. So if I come up here and I just put 9 over 7 in here for x, it doesn't make any of my denominators 0. So 9 over 7 is a good answer. Now, another way that you can go ahead and ahead of time see what x cannot equal, if you wanted to take all your denominators that have a variable, you could set it up and set them equal to 0. So in this case, it's just x. So x cannot equal 0. So if I would have solved my problem, and if I would have gotten x equals 0, then my answer would have been no solution. And you're going to see this a little bit better when I do a couple more examples. So 9 over 7 is a good solution. All right. So for number 5, now you can go ahead and whenever I have something that looks like this, I'm just going to solve this as if it's a proportion. So all I need to do is the cross products. So I'll multiply this times this, and this times this. So when I go to set this up, it's going to end up being 2, this diagonal, 2 times 10x plus 3 equals the pink diagonal, 5x plus 6. So I'm going to go ahead and distribute. I get 20x plus 6 equals the 5x plus 6. I need to start to get my like terms together. So I'm going to subtract the 5x. I get 15x plus 6 equals 6. I'm going to subtract 6. I get 15x equals 0. Divide by 15, and x equals 0. Now, I need to plug that 0 in because I had an x in the bottom of one of my fractions. However, when I come up here, and if I put a 0 here for this x, I get 5 times 0 is 0, but it's still 0 plus 6. This denominator is still a 6. It's not a 0. So x equals 0 is a good answer. Now, one way that you can do this to figure out what x can't be is you can take this denominator. This is what I said in the other problem. Take this denominator, set up an equation, and say 5x plus 6 cannot equal 0. So the only thing that would make that denominator a 0 is when x is equal to negative 6 over 5. So if I would have gotten negative 6 over 5 as my answer, then the answer to this question would have been no solution. So you can either do that initially, figure out what x cannot be, or you can just solve it like normal and then plug it in. You have to check for extraneous solutions. All right, number 6. I need to find the common denominator. Remember, I can't just say, oh, I'm just going to add a minus 5 here. Doesn't work that way. My common denominator is both of these. So I'm going to be multiplying all the terms by x times x minus 5. So I'm going to multiply that to the first one. I'm going to multiply it to the next one. And to the answer. However, if you notice, we're timesing it by a 0, and 0 times anything is just a 0. So really, I don't need to show that, but I will. Okay, so now for the red one, notice what's going to cancel here is just the x. So now I need to distribute the x minus 5 to the 1. which just gives me x minus 5. Then the blue, what's going to cancel is going to be the x minus 5. So now I'm going to multiply the 2 and the x, so I get a 2x. And then the purple, anything times 0 is 0. And now I need to combine my like terms. So I have a 1x here plus 2x, and this is going to give me 3x minus 5 equals 0. I need to get x by itself, so I'm going to add 5. 3x equals 5. Divide by 3. And x equals 5/3. Now again, we need to check it. So if I plug in 5/3 up here, doesn't make that one a 0, and it doesn't make this one a 0 either. 5/3 minus 5, it's just going to give me a negative number. It's not making any denominator 0, so it's good. Now again, if you wanted to, at the beginning, show what x cannot equal, so this is good. You could have also taken the denominators. So the first denominator here, this x, set it not equal to 0. So if you got x equals 0, the answer would be extraneous. And then for this one, the x minus 5, not equal to 0. So the two numbers that would make the denominator a 0 would have been 0 and 5. And I didn't get that. I got 5/3, so my answer is good. Let's try number 7. Now again, if you want to take these two denominators at the very beginning here and say, you know what? Let me check to see what x can't equal. And then if I get that, then I can just say no solution. So here I'm going to quickly subtract. I get 2x equals negative 1. Divide by 2. So x cannot equal negative 1/2. And then if I do the same thing over here, 2x equals 1, divide or not equal. So x can't be positive 1/2 or negative 1/2 if I get that as my answer. So let's go ahead and let's solve this. Again, your common denominator is both of these. So I'm going to multiply each term by 2x plus 1, 2x minus 1. And then the second one, 2x plus 1, 2x minus 1, 8x over 2x minus 1. And then finally the answer also gets multiplied. So 2x plus 1, I guess I shouldn't do purple. It's going to go in there and it's not going to be able to see it. Let me do a different color here. So 2x plus 1, 2x minus 1, and then I multiply that to the negative 4. Okay, so now for the first one, the blue, notice the 2x plus 1 is going to cancel. So now what I'm going to be doing here is multiplying 7 times 2x minus 1. Then the red, what's going to cancel here is going to be the 2x minus 1. So again, what I need to do is distribute the 8x to the 2x plus 1. Now, for the answer here, I need to multiply these three things. So if you want to FOIL the first two and then distribute the negative 4, you can. It doesn't really matter the order that you multiply here. So if I FOIL the first two, I get 4x squared, and then outer and inner are going to cancel, minus 1. And then now I'm going to distribute the negative 4. So then I get negative 16x squared plus 4. So now I'm going to distribute the red and the blue. So this blue becomes 14x minus 7. The red becomes negative 16x squared. Now I'm distributing this as a negative 8. And then this becomes a negative 8x. and then it's equal to negative 16x squared plus 4. I now need to try to group my like terms together. Before I do that, let me add the 14x and the 8x, and this will give me 6x minus 7 equals negative, and I also have, sorry, the negative 16x squared. All right, now when I try to group my 16x squareds together, notice they're going to cancel on both sides. So these are gone. And then now I'm left with 6x minus 7 equals 4. I'm going to add my 7. And I get 6x equals 11. Let me move it over here. Divide by 6. And x equals 11 over 6. Now, if you remember, we already did what x can't equal up here at the top. If x were to equal 1/2 or negative 1/2, then my answer here would be no solution. But my answer is 11 over 6, so this checks. You could also have just plugged it in. You don't have to do this at the beginning. You could now plug in 11 over 6 into these x's to make sure it doesn't make any of the denominators a 0. Let's try number 8. Remember, when you're finding a common denominator, you need to factor first. Because if you say your common denominator is going to be x minus 2, x plus 2, and then x squared minus 4, you're going to get an ugly mess. Do not do it, okay? My common denominator, after I factor this one, is just going to be that. It's going to be x minus 2, x plus 2. So let me go ahead and multiply each one of my terms by that LCD. So I'm going to multiply x minus 2, x plus 2, times the 1 over x minus 2. Then the next one, x minus 2, x plus 2 gets multiplied to the 3 over x plus 2. And then the last one, same thing, x minus 2, x plus 2 times 6x over x squared minus 4. Now I'm going to look for things that simplify. The x minus 2 cancels, and now I'm just doing 1 times x plus 2, and that's just x plus 2. And then now the red, the x plus 2 cancels, and now I have to multiply 3 times x minus 2. And then I have the plus sign. And then over here, they both simplify, because that was my common denominator. So over in the answer, I just have, or that's not the answer, just the other term is 6x. And that was a subtraction sign. Let me fix that. This is a subtraction sign here, not a plus sign. So be very careful what you write, because one little sign mistake and everything's messed up. So this is a minus sign. So let me distribute the red. The red becomes 3x minus 6. And I still have the minus 6x and the blue x plus 2. So let me go ahead and combine on that right side. I'm going to combine the 3x minus 6x, and I get negative 3x minus 6, and then the blue x plus 2 comes down. Now let me get my variables together. I'm going to add 3x to both sides. I end up with 4x plus 2 equals negative 6. Subtract the 2, and I get 4x equals negative 8. Divide by 4, and x equals negative 2. Now, notice at the beginning, I didn't say what x couldn't equal, but I could have done that. And then as soon as I got this answer, I'm going to see that it doesn't work. Now, if I didn't do that, which I didn't, let me plug it in. If I plug it in here, -2 minus 2 is -4. That one's good. Nothing happens there. But when I plug it in here, notice -2 plus 2 makes this a 0. So this now makes my answer here no solution. And again, on WebAssign, D and E. Now, if you wanted to at the beginning, you could have taken both of those denominators. The x minus 2, set it not equal to 0, and the x plus 2, not equal to 0. Once you solve this, x could not equal a positive 2, and x cannot equal -2 because it makes the answer extraneous. All right, number 9, LCD. It's going to be the x minus 4. So I'm going to go ahead and multiply it to each one of the terms. So x minus 4 times the 3x over x minus 4 equals x minus 4 times the 5. And then the last one, x minus 4 times 12 over x minus 4. So again, I'm going to simplify. This is gone, so I'm just left with 3x equals, nothing cancels here. I have to distribute the 5. So this becomes 5x minus 20. And then the purple, the x minus 4 cancels. And I'm just left with 12. I need to combine my like terms. I end up with 3x equals 5x minus 8. I need to move my 5x to the other side. I get -2x equals -8. Divide by -2, and x equals 4. Now I got to check it. Notice when I plug it in, 4 minus 4 is 0. No solution. Okay, again, if at the beginning, if you wanted to say x minus 4 cannot equal 0, add 4. So x could not equal 4, and that's what I got. So it's no solution. There will not be any value of x that would make that equation true. Let's try number 10. So here, my common denominator, it's already factored for me. Everything's nice and pretty. It's both of those. It's the x minus 1 and the x plus 3. Now, if you want to just, up here put that you're multiplying it by x minus 1, x plus 3, same thing here, x minus 1, x plus 3, x minus 1, x plus 3, and then cancel stuff. Both of these are gone, so here you're just left with 12. This one, the x minus 1 cancels, so you're left with, on this one, 3 times the x plus 3. And then the last one, what cancels is the x plus 3. So on that one, you're left with 2 times x minus 1. Now, if you'd rather just write it one time, I find it easier so you can get yourself the visual to see what cancels. So let me go ahead and distribute. So I have to distribute the blue, 3x plus 9, and then the red, 2x minus 2. Then the 12 equals comes down. I'm going to combine my like terms. So 3x plus 2x is 5x. And then I can also combine my 9 minus 2, and I get 7. And now I need to get x by itself by subtracting 7. And I get 5 equals 5x. Divide by 5, x equals 1. And again, once you come up here and plug it in, 1 minus 1, this makes a 0. Anything times 0 is 0. So this answer, no good, no solution. And again, you could have set the two denominators equal, the two LCD pieces not equal to 0 at the beginning. And you would have found that if you got 1 or if you got -3, the answer is no solution. And again, on WebAssign, you're going to enter DNE. Now on the quiz, if you put the circle with the slash, or if you write no solution, all of those are acceptable. Or even if you put DNE. Let's try number 11. We need to factor that answer's denominator before we make our LCD. So this last one will factor into x plus 3 and x minus 2. So that's my LCD. So again, if you wanna, now you could also just write it one time and then just remember to distribute to everything. Whatever's gonna work best for you. You know, it gets kind of messy when you try to cancel things. So that's why I like to write it one next to each one. So if I write x plus 3, x minus 2 times the first term, then the next term, same thing, x plus 3, x minus 2, 3 over x plus 3, and then finally the answer, x plus 3, x plus 2 times 4 over x plus 3. I'm going to write what I got when we factored it. Okay, so on the first one, you can see that the x minus 2 cancels. So then you're just multiplying x plus 3 times 1. So you're just left with x plus 3. For the red, the x plus 3 cancels on this one. So you have to distribute the 3 to the x minus 2. And then on the final over here on the answer, the denominator cancels and you're just left with equals 4. So let me go ahead and distribute the red. 3x minus 6. Drop down my x plus 3 and my 4. Combine my like terms. So 1x plus 3x is 4x. And then 3 minus 6 is -3. And now I'm going to add the 3 to both sides. And I get 4x equals 7. Divide by 4, and x equals 7 over 4. Now if I go up and I plug it in, plugging in 7 over 4 into either of these does not make anything a 0. So 7 over 4 is a good answer. And again, you could have, from the very beginning, said that x cannot equal +2 and x can't equal -3. So if you went ahead and did this at the beginning, you could already see that when you got 7 over 4, it was going to be an okay answer. One last example. So here what I need to do is look for my common denominator. I need to factor this thing first. I'm going to factor out a GCF. And notice once I factored it, that's my LCD. So again, I'm going to multiply each term by that LCD. Then the next one, x times x plus 3, 2 over x plus 3. And look what I did again. This is a subtraction sign here, not an addition sign. So be very, very careful when you're writing down your problem. So this is a subtraction sign that's going right in here. And then equals, and then it's going to cancel out. It's the x times the x plus 3 over 3x plus 5 over x times, I'll just put it in the factored form. All right, so for the blue, what's going to cancel r is the x. So what I have to do is distribute a 6 to the x plus 3. What's going to cancel here is going to be the x plus 3. So I'm just multiplying -x times 2, and I get negative 2x. And then on the other side, the denominator fully canceled, so I was just left with 3 times x plus 5. So let me distribute. The blue becomes 6x plus 18 minus the 2x equals 3x plus 15. I need to combine my like terms here. This becomes a 4x plus 18. And then now I can move my x's together by subtracting 3x. And I get x plus 18 equals 15. Subtract 18. And x equals negative 3. Now, if we go and plug it in, as soon as I plug it into one spot, as soon as it makes one of these denominators a 0, which right here it does, then this is no solution. And again, from the very beginning, I could have figured out what x couldn't be. And if I did that, x cannot be a 0, and x cannot equal negative 3. That is it for your notes on solving rational equations.